All right, one last example of the chi-square test, another test of independence. So let's say we have a survey of political affiliation was asking the question, are you in favor, against, or have no opinion of a proposed tax credit for profit universities? And below are the responses. And what we're trying to determine is that the party affiliation is dependent upon the response. And we're going to test this at the 5% significance level. So null hypothesis is that party affiliation and voting preference, or however you want to state it. So I'm going to say, and type of vote are independent. Okay, and then the alternative would be that they are dependent upon one another. So HA, party affiliation and type of vote are dependent. When we draw the distribution, we have to first find the critical value. So in this case, we know that the number of rows R is going to be equal to 3 and columns is equal to 2. So we have 1, 2, 3 columns, and then we have 1, 2, 3 rows, and then we have 1, 2 columns. So to get chi-square critical is going to be equal to degrees of freedom, which is 3 minus 1 times 2 minus 1, which is 2. So we have 2 degrees of freedom. Significance is 5%. And so that means that if we look into the table, the critical value at 2 degrees of freedom, so we have 2 degrees of freedom and 5% significance, that's going to be 5.991. I'm going to delete the table since we don't need it anymore. And let's erase this. So now we have 5.991. And we're going to draw the distribution. Right. 5.991 is the cutoff. 0 to infinity is going to be the range of values for the chi-square distribution. All right, so now we're just going to go ahead, and unfortunately we have to go through and compute what the test value is. Now I'm just going to copy this down really quickly so that way I can see it, so that way I don't have to keep boggling or going back and forth. All right, so we're going to draw our box. All right, we're going to put all the values in the box, and remember we have to come up with both an expected and observed values for each of those. All right, so I'm just going to make the box pretty big this time so we can house all those values. All right, and we had 3 rows and then 2 columns, so right down the middle. And remember, we don't necessarily have to have the titles for everything. All right, so we have an observed of 20, we have an observed of 40, we have an observed of 30, we have an observed of 60, we have an observed of 10, and we have an observed of 20. Right. Now remember, we have to find the row totals, so I'm just going to abbreviate that RT, and then we also have to find the column totals to be able to find each of the expecteds. Fortunately, the row totals are easy. 60, that's a 30, I think. Yep, that's a 30 in English. So 90, and then 30, so that's a 10. And then for the column totals, we have 1, 2, 3 is 60, and then 120 for the other column totals. So now we can go through, we can find each of the expected values. We know that the grand total is going to be 180, and we can get that by either adding the columns together. So we can either do 60 plus 120, or we could do 60 plus 90 plus 30. Either way, it's going to end up giving us 180, and that's what we need to do to check to make sure that we've gotten the correct values there. The first expected is going to be equal to 60 times 60, okay, and we're going to divide that by 180. And again, just to remind you how you get that, what you do is you look down and you figure out the column total, and then you go across and you figure out the row total. Okay, so that's 60 times 60 over 180. I'm going to get rid of those just because we don't need them anymore. So 60 times 60 divided by 180, and that's going to be 20. So that's good because the observed and the expected are identical. So that's going to make that computation really easy. To get the next one, you just go across and you go down to be able to find what the row and the column totals are. So that's going to be 40. So the next expected is going to be 60 times 120 divided by 180. And that's going to be exactly 40. All right, so far we're in good shape. Next expected, that's going to be 60 times 90. And that's going to be divided by 180. So 60 times 90 over 180, and that's 30. 60 times 120 divided by 180. I'm sorry, 90 times 120. So 90 times 120 divided by 180. So expected is 90 times 120 divided by 180. And that's going to be equal to 60. So this is becoming really easy for us so far. And for the last one, we have 60 times 30 divided by 180. And that's exactly 10. And finally, 120 times 30 divided by 180, and that's 20. All right, so the last expected is going to be 120 times 30 divided by 180, and that's just going to be 20. All right, so the really good news about this one is that every observed and expected are the same. All right, now that doesn't really happen that often in real life. It just so happens in this example that they were really nice to us when they did this. Okay, so we have an O column, we have an E column, and then the rest of it's going to be really easy because everything's the same. So we have 20, 40, 30, 60. And then I think it was 10 and 20, but I'll check it. 2, 4, 3, 6. So 20, 40, 30, 60, 10, 20. Right? And we know that each of these is the same. So 20, 40, 30, 60, 10, 20. And that means that all the other columns, O minus E square, and then O minus E square divided by E, it's all going to be 0. Since 0 squared is 0, and it doesn't matter what the denominator is. For instance, 0 over 20, 0 over 40, 0 over 30, etc. They're all going to be 0. Okay, 0, 0, 0, 0, 0, 0, and that makes our test value 0. All right, so this one ended up being really easy. We go to the top, we plot 0 on the distribution. 0 is less than 5.991. All right, so 0 falls right here. So chi-square is equal to 0. And what that means is that there is not evidence to suggest that there's any any dependence with party affiliation and the type of vote that occurs. All right, so we can say that the test value falls in the fail to reject region. Hence, there is no evidence to suggest that party affiliation and type of vote are dependent, not independent, but so party affiliation and type of vote are dependent. Okay. All right, so this doesn't happen often. All right, in fact, it's the first time I've ever seen this happen, and it's probably because it's a problem I pulled out of a textbook, and they probably intended it to happen like this. Okay, so make sure you're okay doing this type of test. Obviously, this is a difficult test because of being able the number of computations to compute the test value.